everybody, welcome to our 11.1 notes. In chapter 11, we're going to be dealing with quadratic equations, inequalities, and functions. And we're going to start out by different methods of solving quadratic equations. In 11.1, we're specifically going to look at a review of factoring, and then solving by the square root property. So a quick review of factoring, which you guys did last chapter, but we can do it again. To solve by factoring, what you guys are going to do is set the equation equal to 0 first, and then use the zero factor property, which says that if a couple of things multiply to equal 0, the only way that's going to happen is if one of those things is 0. So if a times b equals 0, then either a is 0 or b is 0. That's the only way that's going to happen. And so once you factor it, you can set each factor equal to 0 and solve. If you need a review of factoring, that's in chapter 5, okay? So review factoring in chapter 5 if you need to. So let's do a couple quick examples of solving by factoring, okay? And obviously this doesn't work for all quadratics, it only works for quadratics that factor, okay? First one I have in example 1a is x squared plus 14x plus 13 equals 0. Good news, it already equals 0, so we're ready to factor it. So it is a trinomial, so I'm going to do guess and check factoring. It starts out with a couple sets of parentheses equal to 0. First times the first should equal x squared. So x times x equals x squared. The last times the last should equal positive 13. So with it being positive, I know that the signs are the same. Looking at the middle term with it being a positive 14, I know that they're both adding. Plus and plus. To get to 13, which is a nice prime number, the only way we're going to do that is 13 and 1. Then you double check, so the outside times 1 is x. The inside, 13 times x is 13x. And 1 plus 13x equals 14x, which is our middle. We factored it correctly. Okay? Once you've factored it, set each factor equal to 0 and solve. So my two factors are x plus 13 equals 0, and my other factor would be x plus 1 equals 0. Okay? Then you solve your little equations. So if x plus 13 equals 0, I would subtract 13 from both sides, and I would get x equals negative 13. If x plus 1 equals 0, I would subtract 1 from both sides, so x would be negative 1. So we get two answers for these, and in case you're wondering, you're always going to get two answers. Sometimes you get duplicate answers, but you're always going to get two. And I can tell because the highest degree, my highest exponent, is 2. Okay? Let's try another one. In example 1b, we've got 2x squared minus 3x equals negative 1. This one does not equal 0 yet, but it's not difficult to get there. But that's the first thing I'm going to need to do is add 1 to both sides. So I'll have 2x squared minus 3x plus 1 equals 0. Then I'm ready to factor. And yet again, I have a trinomial. I'm doing guess and check factoring. Okay. So the first times the first should equal 2x squared. So really my best option there would be 2x and 1x. The last times the last should multiply to give me negative, or should multiply to give me positive 1, which means that my signs are going to be the same. Looking at the middle term, my signs are both going to be negative. Okay? And then the only way to get 1 with integers is going to be with 1 and 1. Then we check to see if it worked. So my outer product, 2x times negative 1, would be negative 2x. My inner product would be negative 1x. And negative 2x plus negative 1x is negative 3x, which is my middle term, which means it's factored correctly. From here, we'll set each factor equal to 0 and solve. So my factors are 2x minus 1, which equals 0. My other factor is x minus 1, which equals 0. Then we'll solve our little equations. In the first one, I'm going to add 1, and then divide by 2. So x equals 1/2. In my second equation, I'm just going to add 1 to both sides, so x equals 1. Okay. And that's how you solve by factoring. So obviously, not all quadratics are factored. They can't always be solved by factoring, so we need to have other methods. So the first method that we're going to look at in 11.1 is called the square root property, which just says if x squared equals k, then to get rid of the squaring part of it, we can take the square root of both sides. Keep in mind that when we take that square root, we can either get the positive or the negative version. So we're still going to get two answers. We're going to get the positive and the negative, because a positive number squared should give us a positive, and a negative number squared also gives us a positive. We'll get the same answer either way. So it's important to have that plus or minus there. Okay, so let's try that. So in example 2, we're going to solve each equation using the square root property. Example 2a, we're going to have x squared equals 16. So to get x by itself, all I need to do is get rid of the squaring. The opposite of squaring is square rooting. So I'm going to take the square root of both sides. So the square root of x squared is just x. When I do take the square root on the other side, hopefully we'll remember to do the plus or minus square root, and the square root of 16 would be 4. So my answers are going to be 4 or negative 4. And if it helps to plug it back in for your brain, 4 squared, 4 times 4 is 16. Negative 4 squared, so that's negative 4 times negative 4 is also 16. They both work. Okay. Let's try another one. In B, we have z squared equals 12. So to get z by itself, I'm going to take the square root of both sides. So then I'll have z equals plus or minus the square root of 12. The square root of 12, we know we can simplify that a little bit, so we should. So 12 is 3 times 4, and 4 is 2 times 2. So you can pull out a pair of 2's. So that means that z would be plus or minus 2 square root of 3. Okay, and you can write the plus or minus symbol, and even my math lab has that plus or minus symbol as well. Or if you would like to write them separate, you certainly can. That would be positive 2 radical 3 or negative 2 square root of 3. Okay. Next up, in part C, we have 3x squared minus 8 equals 88. This one, if you notice, the x squared is not by itself first, so we should absolutely do that first. So let's add 8 to both sides, and then we'll have 3x squared equals 96. And then let's divide both sides by 3 to get the x squared by itself. So then I'll have x squared equals 32. Now that the x squared is by itself, we can use the square root property. So then we'll take the square root of both sides. So x would equal plus or minus the square root of 32. And yet again, we can simplify the square root of 32 quite a bit. Let's see, 32 is 2 times 16, and 16 is 4 times 4. If you want to keep going, you can, but I already see a pair, so I'm going to circle my pair. So the 4 goes on the outside because we could take a pair of 4's out, and the 2 is left on the inside. So x would equal plus or minus, so the positive or negative version, of 4 square root of 2. Okay. Last one in this set is part D. We have x squared plus 17 equals 0. So the x squared is not by itself quite yet, but we need to just subtract 17 from both sides to get there. So I'll have x squared equals negative 17. Okay. To get x by itself, we'll take the square root of both sides. So then you're going to have x equals plus or minus the square root of negative 17. And probably some alarm bells are going off. You're like, wait, I have a negative underneath my square root? Yes, we do. But that means that we're going to have an imaginary solution. We can still write it, okay? And we can still simplify it. So the negative on the end side of the square root means that we're going to have an I that we can take out. So x would equal positive or negative I square root of 17. Keep in mind that plus or minus goes out front. It does not go in the middle. We're not adding those terms together. We're actually multiplying them together. And the plus or minus is just telling us that it's the positive and negative version of it. Okay. So there's our final answer. Next up, all of these down here, we can actually solve using the square root property. So x minus 4, that whole thing is squared, equals 3. Since the entire thing is squared, we can use our square root property to get rid of that squaring. Okay, so if I take the square root of both sides, it's going to undo the square that's here, and we're just going to be left with x minus 4. And on the right side, we'll have plus or minus the square root of 3. Okay, then you need to get your x by itself, and it's x minus 4, so the opposite of subtraction would be adding. So I'll just add 4 to both sides, and x would be positive 4 plus or minus the square root of 3. Or if you want to do plus or minus square root of 3 plus 4, that's the same thing as well. Okay, and that's as far as we can go with that. Okay, let's do another one. We've got p minus 5 squared equals 40. So to get rid of the squaring, I'm going to take the square root of both sides. So taking the square root, I'll have p minus 5 equals plus or minus the square root of 40. And I can simplify the square root of 40 a little bit, so I should. So p would be 4 times 10. 4 is 2 times 2, and 10 is 2 times 5. So we can take a pair of 2's out. Okay? So now I have p minus 5 equals plus or minus 2 square root of, and underneath the square root I have a 2 and a 5. Multiply those together, that'd be 2 squared of 10. Okay? And last but not least, to get the p by itself, I'll add 5 to both sides. So then p equals positive 5 plus or minus 2 square root of 10. Okay. Last one over here is part C. I've got 2x minus 5 squared minus 100 equals 0. If you notice this time the squaring isn't by itself quite yet, but we can get it there pretty easily by adding 180 to both sides. So if I add 180 to both sides, I'm going to have x minus 5 squared equals 180. To get rid of the squaring, I'll take the square root of both sides. So now I've got 2x minus 5 equals plus or minus the square root of 180. And yet again, the square root of 180 can be simplified a little bit, so let's do that. Okay? So 180 would be 2 times 90, and 90 would be 9 times 10, and 9 is 3 times 3, and we know that 10 is 2 times 5. So we can simplify by taking out a pair of 3s and a pair of 2's. Okay? We take out 3's and 2's, 3 times 2 is 6. So I'll have 2x minus 5 equals plus or minus a positive or negative version of 6 square root of, and I have a 5 on the end side that I didn't use. Okay. Then solving for x from here, I would add 5 to both sides. So then I'd have 2x equals 5 plus or minus 6 square root of 5. And then I'll divide both sides by 2. And I'm done. There's my answer right here, is 5 plus or minus 6 radical 5 all over 2. And in case you're wondering, can I simplify that any more? Well, 6 and 2 are divisible by 2, but 5 isn't. So there's not really any simplifying we can do from here. Okay. Alright, we have one last problem, which is an application problem. So we have a formula for the following objects, and it's d equals 16t squared. Here it is. Okay. And d is the distance in feet, t is the time in seconds, and an object is dropped from the very top of the Gateway Arch in St. Louis, which is 630 feet. So there's our distance. How long would it take? So we're wondering what the time would be for the object to fall to the ground. So we're just going to plug in 630 for our distance equals 16t squared and solve for t. Okay, to solve for t, first thing I would do is divide by 16 on both sides. And unfortunately, it doesn't divide perfectly by 16, but that's okay. So then I can take the square root. So then I'll have t squared equals 630 over 16. We'll take the square root of both sides, which gives me t equals 3 square root of 70